Hello. Today we are going to look at the universal set and the idea of the complement of a set. So the universal set, as the name implies, is the universe for our question. So the universe contains all of the matter that we are aware of in existence, and the universal set contains all of the elements that could possibly be involved in the question. And that will vary from question to question, but the universal set will contain absolutely every element that we could possibly deal with in a particular question. Now, the universal set is written as the capital letter U, which is a little unhelpful because we already know something in sets that looks a little bit like the capital letter U, which is the symbol for union. Now, to tell these two symbols apart is fairly straightforward. U being the name for a set, even though it's a special set, it is just a set, is going to be capital U by itself, and it'll be treated like a normal capital letter for a set name. Union will always come in between two other sets. So by context, we will know whether it's union or universe, because we wouldn't write set A, universal set, and then B. We would say A union B. So if there's a U shaped thing in between two other sets, then it means union and will always mean union. If it's out by itself or written in relationship to other sets in the way we'd usually use a set name, then it means the universal set. The other idea we are looking at today depends on the universal set to some degree, and it is the complement of a set, which simply means anything that isn't in the particular set that we're talking about. So we know in a Venn diagram that if we had the set A, what would that look like in a Venn diagram? Well, I have my universal set here drawn as a box. I should actually have U written in for both of these. So inside the universal set, which we can see we draw differently than a normal set. It's a rectangular box as opposed to our circles for our normal sets. So it's a special set, it gets a special shape. And then if we're looking at the set A, it would be anything inside of the circle A. And then A complement, this little apostrophe means complement in maths, is going to be absolutely everything outside of A. So we need the universal set to effectively define the outside of A, because it's everything that's in the universe except any of the stuff that's in A. So we can see that's what we've shaded in here. So if it's shaded in inside of A, that means all of the stuff inside A. That's our set A. A complement is everything except the stuff that is inside of the circle of A. If it's inside the circle A, we do not include it when we're talking about complement. So let's put this to test in an example. So we have the universal set U is A, B, C, D, E, F, G, H, I. A, the set A, we give capital letter A, and then we have A, C, D, and F are in the set A, and in the set B, we have B, C, D, E, and G. So we can see we use our small letters for our elements of our set, and we use our capital letters for our set names. Now let's go through some points that we already know for just a bit of recap. What does A union B look like? Well, that's going to be everything in A and B. So we have A, C, D, and F are in A, and we have a B. C is already dealt with, D is already dealt with, so we are just left with our union is going to be A, C, D, F, B, E, and G. So all of the stuff that is in A or B or both. A, C, D, F, B. We don't repeat elements in our set. E and G. And we close our curly bracket. So that's all of the stuff that is in A or B or both. And then A intersection B would be the stuff that is in both A and B. Now we kind of already figured that out because we can see that we have C and D are in both lists. So they're the only stuff that's in both lists, so they are the intersection. So we have to be in A and in B, in both lists, to be in the intersection. And we're going to use them in just a minute. Let's fill in our Venn diagram. It might have been easier to actually get A union B and A intersection B once we've done our Venn diagram, but sometimes we need to do it without a Venn diagram. So let's fill this in. The way that we are going to work this is we are going to start from the inside of our Venn diagram and work outward. And this will be very important as Venn diagrams get more advanced in the long run. So we start in the middle. So in A intersection B, we've figured out that we have C and D are in here, are in the intersection. They are in both the circle A and the circle B. So we have to put them in the intersection. And we know we have to put a dot next to our elements. So that's the intersection part of A and B done. Then we go out to the parts that are just A or just B. So in just A, there would be A and F. And we have to put in our dots. And in just B, so stuff that's only in B but not in A, would be B, E, and G. And now, how do we fill in the rest? Because we can see in the universal set that there's stuff that we haven't listed yet. So we can see again, we're starting in the center at the intersection and then filling further and further out. So what we can do, now that we've completed the inner part, we go to the outer and we see what's left to go in the outermost part of our Venn diagram. So A is already used up. It's already listed in set A. B is already used up. It's in set B. C is already used. D is already used. E is already used. You can see I'm underlining, I'm checking off each as I'm going. F is already used. G is already used in B. And now when I run through my list, H has not been used. I has not been used. So by underlining and carefully going to each letter and seeing if those letters appear in those lists and underlying or crossing them out if they don't, I'm now able to narrow down what must be in my outermost part of my Venn diagram. So H and I are the only things that are on the outside. So they're in my universe, but they are not in the sets A or B. So that's how I can draw my Venn diagram, start at the intersection, work my way out, and then by underlining or crossing out the bits that I've already used, I can figure out what goes out here on the outer part that's only in the universe but not in A or B. Now let's answer a few quick questions and then get on to our focusing on our complement work. So is the set CD a subset? Remember, our long looking C symbol is subset of A. Well, to be a subset, it means that it must have some or all of the elements of the set we're being asked about, and we can see that C and D are in A. So they are, all of the elements in this set are in the set A. That means that that would be true. So CD is a subset of A because it contains all of the A contains all of the elements in CD. Is K an element of B? Is the element K in B? Well, no, there's no K in my list, so that would be false. That would not be true. Now, let's get on to our complement work. We know all of the stuff that is in A. It's everything that's in this circle here. So A complement is everything that is not in this circle. Everything in the universe that is not in the circle A. So B, E, G, H, and I all meet that criteria. B, E, G, H, and I, none of that is in the set A, but it is in our universe, so we are able to list them out. Now, what does B complement mean? Well, that's everything that is not in the set B. So that would be A, F, H, and I. And these are sets, so we have to write our curly brackets and put a comma in between each of our elements. Now we could get something more complicated like this, but we have to tell ourselves the story of what's going on. This is A union B complement. Well, A union B is all of the stuff that is in A or B or both. And complement means not that. So what's left? Well, H and I are the only things that are left there. H and I. So we exclude everything that's in A or B or both, and we are left with only H and I in our universe. And A intersection B complement, well, A intersection B is the crossover of A and B, the overlap or the crossover of A and B, what's in both. And we want not that, so it's going to be AF, BEG, and H and I. So, terrible curly bracket. So A, F, B, B, E, G, H, and I. Now, cardinal number of B is how many elements are there in B? Well, there are 1, 2, 3, 4, 5 elements in B. And this is not a set, this is us counting up how many elements there are in B. And then cardinal number of B complement would be how many elements are not in B. So everything that is not in B would be the complement of B. So we'd be dealing with A, F, H, and I. So 1, 2, 3, 4 elements are not in B. And that's what we need for the universal set, which is our special set that gets a rectangular box, and it's absolutely every element that we could deal with in the question. And complement means all of the elements that are not in a particular set. And that's what we need for now.